Hello, everybody. My name is Phil Lamar, and welcome to NASA's Ask the Astronomers Live, where we bring real live scientists to answer your questions about the universe. And if you want to find out about any upcoming shows and also see lots of fun astronomy videos, you can visit the Universe Unplugged website. That's universeunplugged.org. And once you're there, you can ask questions of our scientists in the comments section. And if you do, make sure to include your social media handle so that you can get credit for your fantastic question. All right, today, we've got a really nice show for you. We are talking to two astronomers who use different techniques to find and study supermassive black holes at the centers of galaxies. Galaxies, including our own. So, why don't we meet them? First, let's say hello to Dr. Misty Bentz from Georgia State University. Hello, Misty.
Hi there.
Why don't you tell the folks a little bit about yourself?
Sure. Yeah, I'm a professor at Georgia State University, which is in the middle of downtown Atlanta, Georgia. I've been here for 10 years now. It's gone by super duper fast. I came by way of California, where I was a postdoc for a couple of years, and I did my graduate work at the Ohio State University. Go Buckeyes. I'm a cat mom, and I like to knit when I have some free time, and I'm excited to be here today talking about black holes.
Yay. And we also have Dr. Devin Chu, who, like me, is in Los Angeles. You're from UCLA, right, Devin?
Yes, that is correct.
Tell us about yourself and your work.
Sure thing. So I am currently a postdoctoral researcher at the University of California, Los Angeles. That's also where I did my PhD work. I worked under the tutelage of Dr. Andrea Ghez, who was recently awarded the Nobel Prize in Physics. And for some other facts about me, I grew up in Hilo, Hawaii. So Hawaii has always had a special place in my heart. And being in Los Angeles is a great place to enjoy some awesome food. And I've really enjoyed that part of living here in LA.
Excellent. And thank you both for being here. And Devin, I'm really glad that you mentioned Dr. Ghez and the Nobel Prize, because of course, that's why we're doing a show on black holes, because it's hip, it's now, it's the TikTok of astronomy. But let's start with the obvious question. It's a black hole. It's black. It's a hole. It's in space. Space is black. How do you find something dark and empty in the dark emptiness of space?
Well, first of all, that's just the worst name ever for an object. A black hole is actually invisible. It's not black at all. And we tend to think of a hole in the garden as being a place where you've removed a lot of material and left an empty spot. But a black hole is actually when you've taken an object and you've compressed it and squeezed it down as small as you possibly can. And so it's sort of the most full thing that you can create in nature that happens to also be invisible. So it's an invisible fullness instead of a black hole. And we don't, just like we interact with invisible things in our daily lives that we don't even think about, we use a similar way of understanding black holes, which we can't see themselves. So you may be looking out your window occasionally and noticing that the leaves on the branches of the tree nearby are waving around, or you see some bushes waving around, and you know that the wind is blowing even though you can't see the wind itself. And we use a similar observational technique to study black holes as well. We can't see the black hole, but we can see its effects on things around it. So we can see it whipping gas around or moving stars around. And the black holes that I study in particular are black holes that have a lot of gas. If we can bring up figure 1. It's an artist's picture of what they think the superheated gas around an actively eating black hole might look like. And so we can't see the black hole, but we can see lots of light being emitted from this superheated and glowing gas that's being eaten by the black hole.
Oh, and Misty, when you say the black hole is eating, that's the gravitational pull is drawing things into it?
That's right. Yeah, some of the gas is falling into the black hole and the gravity is pulling it in. And that's actually adding more stuff to the black hole. So the black hole is very full, but it's continuing to grow, sort of like you take a snowball and you roll it and it picks up extra pieces and it gets bigger.
Ah, ooh. I'm going to go start searching for those. The snowball equivalent of black holes. It's a snowball that gets denser and denser till you can't pick it up. Wow. So, Devin, is the observational technique that Misty talked about, is that similar to what you use?
The technique that our group has been using is a little bit different, although Misty did allude to it earlier. Like Misty said, we have a video, I guess I should say, that shows how we do this. But as Misty said, we can't actually see the black hole itself, but we have to use things that are around the black hole to basically figure out that it's there. So this video here is showing stars that are at the very center of our galaxy. Those are these colorful orbs here. Mm-hmm. And these are stars that are orbiting around something that is located by that star-like feature at the very center. But as you can see, it's not glowing or doing anything or shining brightly. It appears like nothing is there at all. But just by using the motions of these stars, and we can use like the laws of gravity to figure out that for the stars to be moving this way, they have to be orbiting around something incredibly massive. And this object that we can figure out is actually 4 million times the mass of our sun. To give you an idea of just how massive that is, if we were to take this same idea of, say, the sun were like, say, the mass of like a human, this supermassive black hole would weigh about this, like weigh about as much as the entire Empire State Building in New York City. So if you were to take the Empire State Building, put on a scale, it's like that's basically the difference between the sun and the supermassive black hole.
Oh, wow. And that's incredible. That's a lot of mass. Mm-hmm. That's amazing. All right. I'm stunned and amazed and learning things like about invisible fullness, but we have some questions. This one was submitted from Instagram by @the_Gopi_Jadhav. The question is, this is a good one. Are there supermassive black holes at the center of every galaxy observed by us? And it's a 4-part question, 5-part question. How are they formed? Are they the result of many merged small black holes or the result of something else? So this is a pretty good start to our thing. Misty, do you want to start?
Sure, yeah. So as far as we understand, there is indeed a supermassive black hole at the center of every galaxy. And if we bring up image 3, we know that even if we take our very powerful telescopes like the Hubble Space Telescope and we point it at what looks like an invisible patch of sky, and we stare at that patch of sky for 2 full weeks and just see what kind of light we can collect, we see that our universe is just filled with galaxies. Every point of light in this image, except for 3 or 4 of them, is an actual galaxy filled with billions and billions of stars. And you see that there are various colors and shapes and sizes. And so there's quite a variety. But even within this variety, it appears that every single galaxy does have a supermassive black hole in its center. Big galaxies have big black holes and small galaxies have smaller black holes, which does sort of help give us a little clue as to how they formed. But that's still a really open question. We don't know if the galaxy forms first and then grows a black hole, or if the black hole forms first and sort of builds a galaxy around it. So we have a little bit of a chicken or egg problem, and we don't have a good answer for that yet. And while we do see evidence for small black holes merging together, if you've heard anything about the LIGO and Virgo results with gravitational waves, we do occasionally see that black holes merge together. That may be part of what's going on here, but we don't think that it fully explains how these black holes are formed and then growing through time. So it's likely that there's a variety of physical explanations that are all working together in slightly different ways to grow these black holes, but it's still something that we are actively working on.
Oh, wow. Okay. So we don't know actually, we don't know whether the black hole is the chicken or the egg.
No, we don't. Yeah.
Okay. Let's see. You sort of answered that all the galaxies that we have observed do have black holes at their center. Mm-hmm. Interesting. maybe it's black holes that make them observable. But Devin, let me ask you, if there's a black hole in the center of our galaxy, is that a bad thing? Is there anything we should be worried about?
So I'll say it's definitely not both. It's definitely not a bad thing. It makes it incredibly interesting and an awesome way that we can study supermassive black holes that are really close. I say really close. It's still like thousands and thousands of light years away. So you have nothing to worry about in that regard. But like on that note as well, there's nothing we need to be worried about as well. There is like misconceptions that black holes suck everything and eventually will be brought in as well. We have nothing to worry about. Even though I said this supermassive black hole is incredibly massive and we can see it do amazing things when it comes to moving stars in the region, what we call the sphere of influence, or really the effect that it has on other stars, this sphere of influence actually is quite small. So again, this black hole is located at the very center of the galaxy. We're located toward the edge, and really this sphere of influence very much remains very close to the very center of the galaxy. So we have nothing to worry about when it comes to falling into the black hole or anything like that. We can just keep on observing the black hole as if, with nothing to worry about.
Okay, great. Okay, so it's not like the black hole is absolutely infinite, is just slowly sucking everything in, which couldn't happen because there are other black holes. So if they were all sucking everything in, there wouldn't be anything except black holes. Now, Misty, the image you showed of the black hole, the gas-eating black hole, that's sort of energetic. Could the black hole at the center of our galaxy have once been like a black hole like that?
Yeah, in fact, we think that every black hole at some point, at least once in its history, and there's been about 14 billion years of history in the universe so far, we think that every supermassive black hole at one point in time has gone through what we might call a binge, where it's been eating a lot over a short period of time. Most black holes today are just snacking lightly. They eat little bits and pieces here and there, maybe grazing, you might call it. But at some point, every black hole has gone through a massive binge and has consumed a lot of material and therefore grown a lot in mass during that process as well. And so because we think that applies to every galaxy, we think it applies to our own Milky Way supermassive black hole as well. And in fact, we have actually found some evidence to show us that this might be the case. When we look at some of these eating black holes, we see these big jets of material being blasted out from the regions around the black hole. If we bring up image number 2, this is a really extreme example of a feeding black hole causing a very energetic outburst of material streaming along these two very collimated jets. And so there's high energy particles and lots of light being spit out on these two streams coming out of the center of the galaxy where the black hole is. Now, nothing's coming out of the black hole. This is stuff that never quite made it inside and instead gets blasted out. So black holes are very messy eaters, a little bit like Cookie Monster. If you ever watch Cookie Monster, there's a lot that comes out in addition to the stuff that goes in. So this is the stuff that never goes in, it just comes out. And we actually see some evidence for a little bit of this kind of collimated ejection to have happened inside our own Milky Way.
Oh, interesting. You're changing all of my ideas about black holes.
Yes.
They're not black, they're not holes.
We were thinking Cookie Monster earlier.
Yes, now I'm picturing an invisible Cookie Monster.
Right.
And the crumbs become a universe.
Right.
Or a galaxy, not a universe. Wait, Devin, let me ask you something. Now, talking about our galaxy and the sphere of influence that you were talking about earlier, there are stars that are within that sphere of influence. Is there anything unusual about those stars that are, closer in orbit to the black hole in our galaxy?
That's a really great question. So as we first looked at the orbits of these stars, the fact that we see stars so close isn't that surprising. However, the more that we study these stars, we found out that there is something interesting about some of these stars in particular. So if we bring up image 6, what we learn is that actually a lot of these stars that are closest to the supermassive black hole are what we call very relatively young stars. Now, I say young, but these stars are still about a few million years old. But in the terms of, say, the life of the universe, that is quite young. We would expect stars to be maybe perhaps a billion years old or something. But these are, like I said, just about a few million years old.
Oh.
And this raises a lot of interesting questions, because the way that we expect stars to actually form is we expect, it's kind of like the snowball analogy. We expect these stars to slowly kind of just collapse, get some gas, and just kind of clench up and eventually become a star. Now, the problem is you need kind of a sort of a stable environment for that. And you throw in a supermassive black hole that makes it really, really hard to do so. So that all said, we find these young massive stars so close to a supermassive black hole, it raises a lot of questions of how could these stars have formed, since they could not have formed in the way that I described earlier, where you get a gas cloud and just collapse it nicely.
Oh, wow. What you're describing sounds a lot like the Disney Channel in the mid-2000s. You've got a lot of young stars in a very unstable environment. You know. But yes, Ariana Grande came out somehow. We don't know.
Justin Timberlake and Britney Spears.
Yeah, and they burn very brightly now. So.
See, we don't know. That's amazing. Well, for anyone who missed the beginning, or if you're just have joined us late, you're watching Ask the Astronomers, and we are chatting about the hip, cool world of black holes at the centers of galaxies, our own and others. Now, Misty, Devin, right now we're going to go to some audience questions. Oh, wait. Oh, we have one here from Facebook, from Abino Gopal on Facebook. This is a big one. So I'm just going to say the words. You guys have to understand what it means. So is there any further info on the fact that colliding black holes were detected in the mass gap between 45 and 135, 85 specifically, where they shouldn't exist, as detected recently by LIGO and Virgo? Like I said, didn't understand any of that. Hope you did.
Yeah, I definitely could take a stab at this. So the mass gap refers to, if we look at what masses of black holes are known, where do they exist in terms of how much they weigh relative to the sun? So we know that there are black holes that range in masses from, 5 times the mass of the sun, up to 30, 40 times the mass of the sun. And we call those stellar mass black holes. So they're a little bit different than the ones that we were talking about earlier, the ones that live at the centers of galaxies, where it's 4 million times the mass of the sun, or maybe even 1 billion times the mass of the sun. So the mass gap is really not necessarily a place where black holes shouldn't exist. It's a place where we haven't found any black holes so far. And so finding this black hole that was created by the merging of 2 smaller black holes. So 2 smaller ones merged together and formed one larger black hole that was, I think, 85 solar masses, as our commenter said. That's interesting because we hadn't found masses of that size before. And if we try to explain what sort of masses we expect to be out there, we have a few different ways of doing that, and they give us different answers. And so observations are always really important for constraining our theoretical ideas of the way that things should work, because oftentimes we have a lot of theoretical ideas and they tell different stories. And so we have to then go out and find actual facts and observations to tell us which of those stories is more likely to be correct. So this is interesting because it tells us that maybe the theories that tell us there should never be black holes that are 85 times the mass of the sun, maybe they're not quite right and they need to be tweaked, or maybe there's a better story that's already been developed that will help us understand the universe better.
Wow, interesting. But I guess that's, when you're dealing with observational science, things change as the observations and more data comes in, right?
And we very often find surprises that we never expected. Every once in a while there's that's funny. I didn't expect to see that. What does that mean? And it gives the theorists a fun puzzle to try to figure out what does that mean? How did that get there?
Well, I guess that's the measure of a theory, is how long before someone disproves it.
Right. Yes. it's a fun game we have.
Now, this is just fascinating to me. Devin, obviously black holes are super cool and hip now, but when you were first getting involved in studying them, what drew you to this realm of study?
I sort of stumbled into studying black holes. My first research focused mostly on just like learning about planets in our own solar system, especially Pluto, who's no longer a planet, I guess. But still, like that was where most of my work was during my undergraduate years. And then when I started graduate school, when I talked to Andrea, she told me about how, well, there's a lot of similar analogies when it comes to our planets and then the solar system, and regarding like supermassive black holes and the stars of the galactic center. Similar to like learning about how planets orbit the sun, we can learn about things when it comes to stars orbiting a supermassive black hole. And that's kind of what got me interested. Yeah, I didn't really know I would be studying that full time going to graduate school, but it's really been such a fascinating experience. Like you said, I've learned like so much, and it's been just an awesome field and just so many really great questions that we're still investigating.
Wow. Ah, yes, the love of curiosity. And poor Pluto. Well, at least it's still a Disney character.
True.
Misty,
what got you interested in studying black holes?
Yeah, so I just always thought black holes were cool because they are. So they always just caught my imagination, and I never quite moved away from them. I think the bigger question of how I got interested in astronomy, though, my birthday's on the 4th of July. That every birthday I was staring up at the sky with lots of interesting lights up there. And so it's sort of a natural interest in looking at the sky and wondering what was going on up there, I think sort of led me to astronomy to begin with. And then, how can you pass up black holes? They really are the coolest things out there.
Well, I'm counting on you to figure out a way to shoot fireworks into a black hole.
Okay, I'll get to work on that.
That'll be your birthday present someday. Now, for you guys, you're obviously on the cutting edge of the hippest part of astronomy. What's next for you guys in your study of these massive black holes? Devin?
Sure, there are so many fascinating questions. Specifically, I can address a few that are specific to the ones that are focused, specific to the black hole at our center of our galaxy. So if we throw up image 5, as we continue to study the supermassive black hole at the center of our galaxy using these ground-based telescopes, there's a lot of interesting questions. One of the things we can start to do now is, now that we've looked at these stars that orbit the supermassive black hole for all these years, we can start to see if perhaps, is Einstein right? Like Einstein and predicts how these stars should be moving around a supermassive black hole. And we're at the point now where we can start to see, is he getting it all right? Are all the things that he predicted holding true? So that's definitely one of the interesting questions that we're really interested in. Does gravity work around something incredibly massive? Something I'm also really interested in, like those big blue massive stars I talked about earlier. I'm really interested in finding if any of them are actually what we call binary stars or double stars, because this can explain perhaps how these interesting stars could have formed. So there's plenty different questions that we can really want to know. And there's definitely a lot of things that a lot of work yet to do, especially when it comes to studying supermassive black holes.
Okay. All right. So Devin is going to figure out how to get to Tatooine. And if you wind up disproving Einstein, I'm going to have to put you on a call with my father-in-law, because he will be very happy to hear that. Misty, what's next for you?
Well, I am super excited about the launch of the James Webb Space Telescope next year. They're telling us October of next year, so we'll see how that holds. But I actually have one of the very first approved programs to play with JWST and test out the new instrumentation there. So it's always fun to play with new toys and see what we're going to get. And we will be studying the center of a very nearby galaxy that has one of these happily eating black holes. And we're going to test how well we can measure the mass of that black hole through its gravitational force on all that hot gas that it's eating, and really compare that to the measurements we've been able to make in the past so far, and try and figure out how well these new tools can help us answer some long-standing questions that we've had about how the black holes in the centers of these galaxies influence the galaxies and how the galaxies themselves influence the black holes. We know that they grow and change with time, and they seem to have influence on each other. And exactly how do those processes work, and then how does that shape what the galaxy looks like as time progresses throughout the universe? So that's what I'm excited about, and have been excited about for a few years, as that deadline keeps getting pushed a little back and a little back. But we want them to get it right, and so we're willing to wait, and we'll just be a little patient a little bit longer.
Hey, the black holes are hundreds of millions of years old. We can probably wait another couple months, right?
I think so, yeah.
That's amazing. And just the fact that you guys are able to measure things that are so far away, that's just crazy to me. All right, let's wrap it up now that we know where you're headed next, business-wise. Do you guys have anything you'd like to say to the folks who are watching today? Just final thoughts about either black holes or science or you, whatever. Devin?
Sure. Well, really, as this was sort of addressed in the previous question, one of the things I want to close with is that there's just so much more that we have yet to learn. And it seems like the more that we continue to learn about supermassive black holes, the more questions arise, and the more that technology yields better scientific evidence and observations, the more questions we get from those. So I just want to say the future is very much bright for black holes if you're interested in studying them. So I just highly encourage you to keep asking your questions, to keep thinking and wondering about what could be, because chances are there's just going to be a lot of time and a lot of questions that we need to keep studying. So definitely stay curious. That's something I would definitely like to say as the final thought.
All right. Misty?
Yeah, so I think, anybody who really likes to solve puzzles and think about big thoughts, there's definitely a place for you in astronomy. We study really impressive objects all the time, things that will kind of blow your mind or make it hurt a little bit. And so if you like to think about big questions and you like to solve puzzles, then astronomy could use your talents, no matter what background you come from. And in fact, having lots of people with lots of different life experiences brings more creativity into solving these really difficult problems. And so, I would just encourage anybody who's thought about it to just reach out to someone they might know, or do a little bit of research online and see if they can get some of their questions answered, to see if that's a path you might like to follow at some point too. I didn't know any scientists when I was growing up, and here I am today. So, you could always tweet at me and ask me your questions. And there are lots of other scientists out there that are a lot more publicly visible than they may have been in the past. So don't be shy, jump right in. There's room for you.
Okay. Well, I would just want to say thank you to both of you for bringing your experience and your perspective to this. It's really incredible, because you guys are putting a face to, and strangely, it's not the face of someone with a long gray beard, which is usually what we think of when we think of astronomers.
Right.
But it's so cool to hear you guys. And since we were talking about young stars, I'm going to go pitch a show to the CW called Young Doctors in Space. Because you guys doctors, look at you, you're so young. But anyway, this has been really cool, very fascinating. Thank you for joining us. And for those of you watching, thank you for joining us to learn about massive black holes at the center of the galaxies. And this video you'll be able to see along with all of our other Universe Unplugged videos at universeunplugged.org. Or you can just click on the link in the comments wherever you're watching it. Please subscribe to us on YouTube, and you'll be the first to know when our next video is coming, or follow us on Facebook to catch our live show, however you want to do it. We have many platforms. Not quite an infinite number, not yet, but a lot of them. And until next time, I'm Phil Lamar, and you've just watched Ask the Astronomers Live. Thank you very much.